Yes, class. Am I audible to all of you? Sabiha, Shaima, Zainab,
Yes, sir.
Hashid. Just all right, class. So we had started with acceleration in the last class, right? Velocity was completed, and we had started with acceleration in the last class. Now see what was acceleration that we have studied. Acceleration distance. First, initially we had studied about distance. So what was distance? Distance was basically the length or the path covered. Then we had seen if distance is changing with respect to time, then we get a quantity that is velocity. Then we had seen speed. If distance was changing, we had seen speed. If the displacement was changing, we had seen it was velocity. Now if velocity is changing, we get acceleration, means rate of change of velocity. If velocity is changing with respect to time. I'm not audible to all of you.
Ma'am, you're audible.
I'm audible, no? Harshit, check your connection. Just check. I'll write it for you. Okay. Yes, so acceleration we had seen. Now, this part, have you all written? The definition part of acceleration? Audible now. Okay. Yes, have you all written this part? Yes, no.
No, ma'am. No, ma'am.
Just write in the chat column, class, please. You have not written this acceleration part. All right. So acceleration is what I'll tell you. Just I'll give you time. Right now, do not write down anything. Acceleration is basically rate of change of velocity. If your velocity is now changing with respect to time, then we have acceleration. So we have various. Similarly, we have uniform acceleration. If equal amount of velocity is changing in equal intervals of time, this means, see, this is some velocity v1 3 meter per second in time, let's say 4 seconds. This is another velocity, this is 3 meter per second, again in time 4 seconds. So this part is uniform acceleration. So velocity is changing with respect to time. This is uniform acceleration. Suppose in this situation, I have the velocity v3, this is v2, this is t2, this is t1, v3 as 4 meter per second, and T3 as 8 seconds. So see, now this is non-uniform. So the definitions are again the same. The definitions about the uniform and non-uniform. In non-uniform, again, you have the case of average and instantaneous. Last day also we have discussed this case of average and instantaneous. So you have the same case of average and instantaneous. Means if the duration is given to you, you will calculate average. Remember, if we had the duration, we used to calculate average velocity. Now you have the average. If you have the duration, you will calculate the average. If you are calculating at any instant for a particular time instant, if you have any time instant, then you will use instantaneous, where you will differentiate if the time is given to you. But if the time is not mentioned to you, duration is given from some time to some time, from 2 seconds to 3 seconds, 2 to 4 seconds, like this. If it is given, then you will use average. Same thing for average, you will divide. For instantaneous, you will differentiate. Same things, whatever you've studied for velocity. So it's a vector quantity, and SI unit is meter per second square. CGS unit will be centimeter per second square. Now look at this first question, then you can write down all these things together. See, a body is started with a velocity 2 meter per second. At B point, the velocity is 5 meter per second, and the total duration that took here is 10 seconds. So what is the change in velocity? what is the change in velocity? So basically, you have the change in velocity as 5 minus 2, that is 3 meter per second, correct? So acceleration will be the change in velocity by the time duration. Change in velocity is 3 meter per second and time is 10 seconds. So you have the answer as 0.3 meter per second square. This is how you have to calculate the change in velocity by the duration. So acceleration, when you are calculating for average, let me write it down there. Wait. If you are calculating it for average, so acceleration would be change in velocity by change in time. Simply divide it. All right. And if you are calculating instantaneous, so it will be dv over dt. Acceleration would be dv over dt, like this. Remember this because this is helpful when you're solving the questions. Write it down. Write it down from here. Yes, class. Now see differences between uniform and non-uniform acceleration. So this I have told you, see, if you see that velocity is changing every time. This is V1, this is V2, V3. If velocity is constant, suppose here it is 2 meter per second, here it is 2 meter per second, here this is 2 meter per second. Here we have time T1, here we have time T2, here we have time T3. Suppose the time duration here is also 4 seconds, here is also 4 seconds, here is also 4 seconds. So see, every time when you are calculating acceleration, suppose you are calculating acceleration here. So A1 will be 2 by 4. A2 will be here 2 by 4. A3 here will be 2 by 4. So everywhere you see acceleration is 2 by 4. This shows that value of acceleration is constant. Suppose this is not the thing. We have V1, V2, V3. Suppose here velocity is 2 meter per second, time duration here that is passing is 4 seconds. But the velocity is increasing and becoming 3 meter per second and time duration is still the same. Now velocity is still 3 meter per second, but now the time duration has increased to 8 seconds. So see, everywhere when you will see acceleration value is different here. The value of acceleration is different. A1 here is 2 by 4, A2 is 3 by 4, A3 is 3 by 8. So see, all the values of acceleration, this is different. All right, so this is what it is about. Just write down this question, write down from here and then write down that question. Okay, only Shaima has answered till now. See, this says that a car moving with velocity 10 meter per second means a car is moving with velocity 10 meter per second. Takes a U-turn in 5 seconds. Alright, and it continues to move with the same speed. Means this was moving here. Now this is moving here with 10 meter per second. And the time taken is 5 seconds. Calculate the acceleration. See class. Acceleration is rate of change in velocity. Is the rate of change of velocity. Formula also I have told you that this is delta V by delta T. Means final velocity minus initial velocity or final time minus initial time. This is how we write acceleration. So this is here. If this side, suppose let's take right hand side, let's take positive, and left side, then we have to take negative because these are vector quantities. That this we'll study in vectors also. So right side, this positive side, this one. So this velocity will become plus 10 and this velocity will become minus 10. So what is the change in velocity? V2 minus V1 when you do, you have to write V2 minus V1. No? This is how you're calculating the change in velocity. Are you getting it? Okay, okay, just take 2 more minutes. Okay, okay. No, 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 not 0. Your answer was right. I'll tell you. Okay, let me discuss then. See, you people, just understand, you'll be able to understand. Right is positive, left is negative. You have to follow the sign convention. In motion in one dimension, you have to follow the sign convention. This means one side has to be taken positive, other side has to be taken negative. You can take right negative, left positive. This depends on you. Now see, suppose this is V1, this is V2. This is the change in velocity, right? So what is V2? V2 is minus 10. What is V1? V1 is 10. This becomes minus 20 meter per second, the change in velocity. So acceleration is change in velocity divided by whatever is the change in time. Change in velocity is minus 20, time was 5 seconds. That question was also left. No, second part was left. I'll discuss after this question, after this acceleration part. This is minus 4 meter per second square. Now see, what is this minus sign signifying? Minus sign is signifying the direction because these are vector quantities. So this minus sign, this is basically signifying the direction. All right, this is basically signifying the direction. Negative sign. What was the negative sign that we had chosen? We had chosen left as negative. It means this direction of acceleration, this is towards the left side. What is the meaning here? Suppose I had taken right as, even if you take here in this question, if you take right as negative and left as positive, look, what was the right hand side direction? It means you will take V1 as minus 10. You will take V1 as minus 10 meter per second. You will take V2 as plus 10 meter per second. Right? This is what is saying if you choose this sign convention. This is the method second. You can choose any method. You can choose any sign convention. Now see, V2 minus V1. This is the change in velocity. So what is V2? V2 is 10, right? Minus. What is V1? V1 is minus 10. This becomes plus 10, plus 20 meter per second. Look, When we find out acceleration, acceleration is change in velocity by change in time. What is the change in velocity? Plus 20 divided by 5, that is plus 4 meter per second. Now, what is this plus 4 telling us? This plus 4 meter per second, this is just telling us the direction. Plus, what was the sign plus that we had chosen? We had chosen plus as left. See, through this method also, we are getting the same direction, left side. So magnitude is 4, direction left side. Look at the previous part. Magnitude 4, direction left. So by any method you can go. You can take any direction. It's just that you have to obey this here. In this step, you have to put it. This step here and here. This step. Fine. Now this is clear. So what was your answer, Shaima? 2. Not 2, not 5, not 0. 0, it would not be in this particular question. Write down the second part also we have to discuss of the previous question. That was also left. Yes, yes, write the second method as well. That you remember that you can write it in both ways. All right, let's now complete this part which was left. Instantaneous velocity was also left, and this was also to be discussed. Now, C class, in this question, the first part, is the first part clear to all of you? I think all of you responded with a yes last time. Second question, you were having doubt. See, what was there in this question? A person was moving, a man was walking, he was moving from his home to the market, and the separation was 2.5 kilometers. Then, when he was walking with a velocity 5 kilometer per hour. So it means he is walking with a slower speed. So the time taken is 30 minutes. But when he's coming back, as soon as he went to the market, he had seen it's closed. So he comes back with a speed of 7.5 kilometers per hour. Means he has increased the speed himself, right? So if the speed is increasing, time would be less. अगर जल्दी जल्दी चलोगे so कम time लगेगा, you will reach your destination fast. So similar the thing is here. 7.5 kilometers has increased the velocity of the person, so the time taken is less. Now when we have calculated that distance and time, that is coming 20 minutes. Means it took him 30 minutes to go, and now it is taking him 20 minutes to come back. Tell me, till here, is it clear to all of you? Just give me a thumbs up. Others? Sabiha, it's clear to you? The first part, Sabiha? Yes, Sabiha, you're present in the class? Sabiha, share. Please respond. Okay, fine. Now what we have to do, we had to calculate the average speed and average velocity in the first part. So what we have done, first part, distance was also the same, displacement was also the same. So the calculation part was very easy for us. We have taken the total distance, divided it by the total time, right? So total distance divided by total time, you're getting the average velocity, average speed. So first part was easy. In the second part, now we are having difficulties, right? In the second part, we have to find out. Look here, class, carefully. 20 minutes we have calculated. Now, distance is 2.5 meters. If I half the distance, I will get 1.25 in the first half. I'll get 1.25 in the second half. Means it is taking him 10 minutes to reach the midpoint, then 10 minutes to reach the home. Then only, we can say the entire duration is 20 minutes. From market to midpoint, it is taking 10 minutes. Then from midpoint towards the home, it is taking again 10 minutes. That's why we can say the entire duration is 20 minutes, correct? So 2.5 is getting divided by 1.25 and 1.25, and this is taken 20 minutes, 20. But the question is not asking us what is the time taken or what is the average velocity when the person is going from market to home. The question is 0 to 40 minutes. It's not from market to home that we can simply calculate this 2.5 divided by 7.5 and we'll get our answer again back. No. Because 0 to 30 minutes were over exactly at this point. That's why we had used this. Now it's from 0 to 40 minutes. What is the meaning of the 0 to 40 minutes? Means 30 minutes already when he was walking from home to market. This 30 minutes plus when he will come back, because it is from 0 to 30. 0 means from the home you have to include. From the home part, 0 to 30, I have added. Then again he is moving till this midpoint. 10 minutes are gone. So total 40 minutes means the person would be at this midpoint when he would be going back with a speed of 7.5 kilometers, and the time duration that would be covered would be 10 minutes. Tell me, this is clear? How are we just writing this? How are we plotting this? It's clear? Okay. Now see. We have to first find out average speed. So for average speed, we require the distance, right? For the average speed, we require the distance. Now, the distance that is covered is, see, how much the person has traveled. Firstly, he has gone in this 40 minutes duration in coming back to this midpoint, from going to home to market, then from market to this midpoint. This is the entire duration. From home to market, then market to this midpoint is the total duration for this 40 minutes. So what is the distance? First, he's covering 2.5 kilometers. Then he's covering this much distance, that is 1.25 kilometer. This is it. So you have this 5, this is 3.75 kilometers, right? This is 3.75 kilometers. So average speed is easy. When you are calculating the average speed, you have to find out distance. What is the total distance? Total distance is from home to market, that is 2.5, plus market to midpoint, because he has stopped here. So this is 3.75. This was in kilometers. Divided by, so we cannot write 40 minutes. What was 40 minutes in, see, this is 60. So 20, you have 40 would be 2 by 3 divided by 60. Yeah. 40 divided by 60, 2 by 3. It means 2 by 3 of an hour. 40 minutes is 2 by, just to have the same unit, kilometer per hour, that's why. So 3.75 would be multiplied to 3 divided by 2. This is the rough workspace. So this would be 5.12 kilometer per hour. Tell me, average speed is clear. How have we calculated the average speed? All of you. Just give a thumbs up. I'll understand that you've understood. Others, you want me to repeat? Anyone? Everything is clear. Any specific doubt you have? Harshid, it's clear. Shaima, it's clear. Sabiha and Zainab, it's fine by both of you. Clear to you? Okay. Now see, we have to find out. Yes, I'll repeat the speed part. See, speed is distance divided by time. What is the distance? Distance is the time that this distance that is covered is from how is he going? He's first going from home to market. What is this distance? 2.5 kilometers. Then from the from M point, he is going to the midpoint. This is the midpoint, right? He is going to this point, midpoint. So this is 1.25 from M to midpoint. So what is the total distance? Total distance is 3.75. And I've just converted 40 minutes into hours so that I get the final unit in kilometers per hour. Fine. One more thing, we have to find out the average velocity also. See, in average velocity, we require the displacement. And for the calculation of displacement, what do we require? For the calculation of displacement, we just need the initial and final points. See, initial and final points. Initially, he was going from home. This is the initial point. Finally, he has come to this midpoint. This is the final point. What is the displacement? Can anyone answer? Displacement.
1.25 kilometers.
Very good, Shaima. 1.25. This is the displacement, initial to final. So this total displacement is for the average velocity. So total displacement is kitna tha? 1.25. And again, the distance, is 2 by 3. This is in kilometer, this is in hour. This will be 1.25 into 3 divided by 2. This will be 1.87 kilometer per hour. Yes, correct. 1.87 kilometer per hour. Very good. Write it down, then we'll see the instantaneous velocity part that was left. So till here you have written, from here write it down. From tomorrow onwards, now I have told you initially only that in the starting we are keeping the class duration as 1.5 hours. Now your class duration will increase to 2 hours. So from tomorrow, because you people have your exams also coming. Zainab, Shaima, I have seen your schedule. I'll be arranging your classes. On Monday, I think your class would be arranged. Or tomorrow also it can be arranged after this class. I'll let you know. They will, the team will only inform you. Operations team would inform you. But your class duration will also increase because now we are on the second chapter only. We have to complete this and at least start with the third one. So for the syllabus part, your class duration will be 2 hours. So please be prepared for that. Write it. Now, class C, we have instantaneous velocity that we didn't discuss in the last class. So what is instantaneous velocity? In instantaneous velocity, I have told you at a particular instant when you are calculating, then you write it as the instantaneous velocity when you have a particular time duration. So velocity is dx over dt, means you are differentiating the velocity with respect to time. So suppose I have x is equal to 3t square plus 2t minus 1. This is the equation that I have. So 3t square plus 2t minus 1. Now what I'll do, I'll differentiate this. Because for getting velocity's equation, I have to differentiate this. So what is 3t square? 3 into 2t plus 2. T will become to the power 0. That will become 1. And minus 1 is this is a constant term, so it will be 0. So we have velocity's equation as 60 plus 2. So now we have to find out velocity at t is equal to 1 seconds. So at t is equal to 1 seconds means you will substitute the value of velocity, right? So you will substitute the value of velocity as 1. So this will become 6 into 1 plus 2. So velocity will become 8 meter per second. This is how you have to calculate the questions on instantaneous. Instantaneous also you have to calculate it in this manner. Now answer this question. Write it down first. See class, for this question, this is giving you velocity and asking you displacement. Remember, I have told you when you have velocity and you have to find out, see, when you have velocity, you have to find out displacement, you write it like this. But right now, displacement is missing. I have told you the integration and differentiation, these are inverse operations. So if this is missing, you can integrate it. Means v dt, you can integrate this to get displacement. This is how you have to do. So displacement would be, what is velocity is equation? 2t minus 1 dt. You have to integrate it from 0 to 2. Just a second, class. Give me a second. See, so integrating it from, the time is given 0 to 2 seconds. So this is how you had to solve this question. Now see, x will be 2t dt, integrating it from 0 to 2. Minus 1, you have, all right, this you have minus 1 dt, integrating it from 0 to 2. So 2 is a constant, t square 1 plus 1 divided by 2 from 0 to 2, minus 1 is itself a constant, integration of dt will give us t from 0 to 2. 2 will be cancelled. Put the time, 2 square minus 0 square. Minus, this is 2 minus 0. So 2 square is 4 minus 0. Here we have minus 2. So answer is 2 meters. How much you have answered, Shaima? Just check now. Check the calculations now. Check the method. So remember, integrate, how to use integration. Write it down. Now class C, I'll not go into the details of this, but at least we'll start with the equations. These are some standard equations. 3 equations are there. These equations we use to find out one of the unknown variables which is missing. So I'll not go into the details of this. This we'll start in the next class only. So, but these are known as uniformly accelerated